Hey there, welcome to the Sudo show. This is Brandon. Just a little bit of housekeeping today. July flew right by. I didn't get as much content out as I wanted for Sudo Show Labs, but there's a couple of videos up on the Sudo Show YouTube channel on the Sudo Show Labs playlist. Please go check it out. And while you're there, please make sure to hit subscribe. It really helps the Sudo Show. Now, for the month of August, we're going to be concentrating on getting back on a cadence, whether that's going to be 2 podcasts a month or a podcast plus the YouTube content around Sudo Show Labs. That's going to be our focus for the month of August. Again, please make sure to go hit subscribe on the Sudo Show YouTube channel so you don't miss any new content. Now here is episode 64. Let's talk backups. All right, so backups, guys. Bill and I recorded an episode a while ago about virtualization, and we touched on this, but I ended up cutting it, mostly due to the length of the episode, and I wanted to do a dedicated episode on backups. Neal, you just came out of a company that specializes in backups, and Bill, you're in the thick of this day to day. I haven't had to deal with this in, 12 years. I've been in sales. So I'll let you guys kick this off. But when I was in ops, there was a lot of process around this. And what's the thought process when you're trying to identify this data to back up? Because I think the biggest thing is deciding what is critical, what is not, and ensuring you're not wasting space, essentially.
So one way I think about defining critical data is thinking about what things can you replace and what things can you not. So, for example, on a Linux system, you probably can get away with capturing your system configuration state using a configuration management tool like Ansible or similar, or Salt or Puppet or whatever, right? You can use these tools to capture how the system is set up, what software you have, the configuration, the whole works. But what you can't do with that is capture what your users or sysadmins or the applications that are on there generate and create uniquely on that machine. That's, colloquially called the user data. That data is what you need to scope and think about for backing it up, or essentially preserving it in some means or fashion. Now, if you look at something like Windows machines, this is a lot harder to do a split on, and so usually you want to consider everything in totality to back up, because capturing that what is the system and the user stat of information and what is replaceable and what isn't may or may not be more difficult depending on how the Windows computer is done. Same used to be true for Macs. Macs are now have much firmer separation between system and user stuff, because the host operating system in macOS is fully immutable. You can't really do anything to it. All of the changes you make onto a Macintosh computer are overlaid in your user state. That even includes application installation, configuration settings, the whole thing there. Like those whole 9 yards, you can easily isolate and capture in some meaningful way. Bill, what do you think? Do you disagree? Do you have other experiences that could add on to it? Provide some of your own color.
Where I work in the Windows world, because everything is virtualized, we capture different points of systems via different means. So one best practice that I can share for the Windows side is back up your virtual machine hosts at the hypervisor level. And pick whatever tool you want. There are many out there, including Acronis, Veeam, Altaro. There are many of them. At the same time, always make sure you have a supplemental backup. That could include something like an agent-based backup, whether you want Synology, Datto, Unitrends, you name it. But having that supplemental backup in the event that your primary fails ensures that you have multiple points of recovery, and you can use that supplemental backup to maybe only pick up parts of that data set that the organization deems critical. So case in point, I have some data sets that you could call them ephemeral. They're not the end of the world if they go. They could be recreated. But I have some other clients that say this one folder here may only contain 40 gigs, but we have to retain that folder for 20 years. We have to be able to go back 20 years worth of data to pull that information. So understanding the criticality of the data set is going to help you not over or under design your backup solution. And Neal, to your point, in the Linux and the Mac world, it's a lot easier to separate out the user data land than it is now within the application data land and your system configuration data land, which allows for exponentially more flexibility than you have in Windows.
With these kinds of definitions that you have and an understanding of what you actually need to keep, I guess the next thing would be to think about is, when and what to back up, which I think we covered a little bit of, but I think we can dive in a little bit more here. And from the Linux side, which is where I have a lot of experience in, when and what you back up comes from what you feel like is a reasonable frequency of change that you're willing to lose. At the end of the day, your backup frequency mirrors your recovery frequency and your ability to tolerate loss. So if you can't tolerate loss more than an hour worth of data, then you need to snapshot hourly and send those snapshots off-site and implement your 3-2-1 strategy to handle this. For those who don't know, 3-2-1 refers to having 3 copies of your data, 2 of them being backups, with one of them being production, and having one that is at least offsite. And whenever you're implementing a strategy around this, right? And this is again talking about risk and how much you need to care about your backup. You need to optimize for what matters, because also how much data you take in and the strategy in which you do your backups also affects how much of a storage outlay you have to take and how much you can tolerate to maintain. And so you have to balance all these factors for when you figure it out. From that perspective, there's a lot of good tooling in the open source software to implement backup processes in the Linux world. I think the most polished one I'm aware of is a tool called Your Backup, URBACKUP, and it's I'll have links to it in the show notes, but it's a neat tool that implements a wide variety of backends for being able to interface with systems that you want to have backups of and pull their data and store them somewhere else. Bill, as you mentioned earlier about having agented backups. Agented meaning there's a piece of software on the system in question that's being protected that actually interacts with the system itself to capture its state and send it somewhere else. Your Backup is an open source solution that does just that. They also have a commercial variant called Inscape. I can't say this well, but INFscape. And it's a Your Backup commercial appliance, but it's fully open source software. You can deploy it on your own, do your thing. It supports Btrfs and ZFS through their native mechanisms. But if you're not using Btrfs or ZFS on the guest machines, the machines you want to back up, it will work with a block driver device, block driver kernel module called DattoBD, the Datto block driver. That, full disclosure, at my previous employer, I helped actually make, release, open source, and support for years and years and years. But that is supported by your backup to be able to do things like backup ext4 volumes, backup XFS volumes, FAT, NTFS, anything that isn't Btrfs or ZFS. It's probably the most polished and most complete one, and also handles backing up Windows and Mac machines with varying strategies for those two. But I can only really speak about the Linux ones because I've tried the Linux backup, because backing up systems is a good idea. And working for a little under a decade at a storage company that focused on disaster recovery really hammers home how much it matters. There's a few other tools out there. If you're using Btrfs as your file system of choice, you've got a tool called Btrback, BTRBK, and then there's another one called Btrfs Backup. These two are not super polished, fancy graphical tools. They're simple command line service utilities that you could configure, and they'll do stuff in the background for you. And based on whatever strategy you set up, they'll take snapshots and then they'll send them off site, and you can implement your strategy however you like for those. For some of these other tools for other types of backup strategies, Bill, do you want to talk about those?
I was taking a look at UR Backup because I had not heard of that before. And in my line of work, I'm always looking for new and different tools. So I was checking out your solution as you were speaking, and I'm going to recommend this to my colleagues. Other open source backup solutions that I've worked with before are kind of one-off per system as needed. Solutions for my Linux stuff, I've worked with Timeshift because I run Fedora on my systems at home. And that's a great way to utilize BTRFS snapshots to send data to a backup destination. I've used SyncThing, I've used DejaDupe, all with varying degrees of success. I have contacts who work professionally with Bacula, which is a commercial open source backup company. They provide support for enterprise backups with their software. But I actually do something a little different. All of my mission critical data at home resides on my NAS. And my NAS has all of the tooling that I need built in. And I use the NAS for snapshots. I send snapshots to an external drive. I keep one external drive at home. I keep one external drive offsite. And I actually have another NAS at my other office that I also send my snapshots to. So I have a variety of ways, but just to keep things simple for me, I wanted one destination to keep my files that I know I could back up and restore to rather easily, thanks to the flexibility of BTRFS.
So you guys talked a lot about file system level backup. And when I look at solutions like UR backup, how I see it is described here, it's file level backup, or even whole operating system. Like if you want to restore the entire operating system in its current state. The way I thought about backups before I left ops was more around what was the best method of backing something up. So most of my background is in databases. Right? That's Oracle or Postgres. And that's where most critical data is. It's in a database, more than likely. So I've became extremely used to using the backup tools for those respective databases and restoring or doing replication. So if we're with DR, we're doing replication. If I'm doing backup, I'll use MySQL set as the example. So using my MySQL dump and moving the database off and backing just that text, essentially, because it's just a text file. When you do a MySQL dump to an S3 bucket, whatever. So I hear from you guys a lot of those like I said, the file strategy. But what about application specific backups?
So application level backups are a very important part of a backup strategy, because when you look at the different ways you do backups, this comes back to testing them and then actually restoring them, because no backup is any good unless you can actually use them to bring things back from the dead. And when you look at each level of backup strategy, you have to think about how fast you can recover. Your recovery time objective, or RTO, is what you actually need to think about. Most of the time, Bill and I are talking about system level backups because while system level backups are expensive, they actually have the fastest RTO. Like, you can plop them back on, put them into a hypervisor, or put them back onto bare metal, and you're hitting the ground running and you're up and running. But it has also got its trade-off of being a lot more data to capture. Whereas application level backups take the opposite approach, right? They're tailored for the workload in question that you care about, and you use the software to pull out the special data that actually matters, put it somewhere, and then have a strategy for using it when you need to recover. Those tend to be slower to recover because it presupposes that you need to set up the system first, then configure the software and bring everything up to the point that you can then restore the data in and have everything work. But it does have the nice side effect of, well, actually intentional effect of having to take less data to do the backup. And this is why at the very beginning we talked about, where's your criticality, and like, do you need to have system data backed up, or can you provide a description or automation to rebuild it? Because being able to use application level backups is practically worthless if you cannot build the system back quickly. For example, in my previous life, I maintained a GitLab system. That GitLab system was essentially impossible to recover in a reasonable amount of time through the application level backups. So it was always a last resort option. To give you an idea of how impossible it is under a reasonable time frame, it took 3 days to put the data back into the system and get everything loaded again. So even though it took more data to take a full snapshot of the virtual machine that it was running on and offsite that, the RTO for that offsite snapshot being returned back or put onto another hypervisor and booted up was an order of magnitude faster. Like, we're talking about hours instead of a day. And so those are the kinds of trade-offs you have to think about. And this, again, comes back to you should test your backups to make sure that they work and that you understand what the recovery process is like. Sometimes you should belt and suspenders so that, again, you have your 3-2-1 strategy. You also have your way of dealing, redundant failover. Again, it depends on the criticality, right? Some systems necessarily require the belt and suspender approach to backups and restores. Some don't. And it's a judgment call to figure out which ones you want to do. But you should always think about these things when you're trying to come up with a backup strategy. What do you think?
So I have a question then for you, Neal. So when we're talking about, and Brandon, actually, you alluded to backing up databases because most critical things kind of live in a database. And it made me think, with the advent and proliferation of containerization, I feel like that's forced organizations to retrofit their backups in a bit of a different way than what they were used to. The old monolithic mechanical spinning rust drive attached to the server doesn't really fly anymore, because in the container world, your storage is a bit separate from your application. I don't really live in the container space, and both of you know what it's like when I start to mess with containers. We've talked about that offline. So I'd like to hear from either one of you of what's a modern strategy then to back up either critical databases or critical files that live in containers. Are you backing those up at the database level using tools like MySQL dumps or PostgreSQL dumps? Or are you more worried about the volumes themselves that the containerized data lives on?
So it varies. The default assumption comes back to, let me rephrase, the default assumption around containerization is that you have already done the separation of system state and user state, because your container image or description or whatever you're using to bring this instance of a container online already fully represents the defined system state. Just run the software, and that is reproducible. So you've already captured that part separately. So now all you have to care about is the persistent instance-specific data. And so by default, most people just don't care about the container part. And what they do is they take volume snapshots or something like that. Because of the nature of how container stuff works, typically the only thing people do is they send what's called a quiescing command to the database, if we're talking about a database workload, and which tells the database that it should hold its writes in memory for a little while you take a snapshot of the volume that it writes to. And once you're done, you tell it that it can stop quiescing, and then it'll commit stuff to disk like normal. This ensures that you have a relatively stable on-disk storage of the database that you can just straight up boot from and it won't freak out. That is the general strategy. Even for regular applications, I think this is the most common way people address dealing with backups and restores and disaster recovery for containerized workloads. Brandon, I care to provide some color or see if or any counterexamples or anything, because I think you've done this a bit more than I have.
Well, there's plenty of utilities that handle this depending on the backend storage. There's utilities for Ceph that will handle it at the volume level. And in some cases with like NoSQL or document style databases, what's the object storage, handling the object storage, whether that, again, Ceph or any other S3 compatible object storage, and handle it at that level is, I think, one of the things you were alluding to. I only brought up the database example to try to prompt the why you do the why you don't necessarily want to restore from the database level. Is when I've restored a MySQL database before that was hundreds of gigabytes in size. A MySQL restore, and if MySQL is properly configured and it's using modern tables, modern table types, it'll take hundreds of gigs will take a couple hours, maybe less. But back in the day, you start a MySQL restore with a MySAM table type, and it's 100 plus gigs, you're going to be there for 4 days, just due to the nature of the way MySAM works.
I want to just say, thank God I don't have to deal with MyISAM anymore. Like, that was when I was a web developer in a very brief time in the early aughts. MyISAM-based MySQL databases were everywhere. And oh my God, were they a problem.
And even with a high-performance database, whether if we're talking modern MySQL or MariaDB or Oracle, it still can take way too much time to restore. That's why in the container world, you may need to do both. You may need to rely on both at the application level and the volume level. But typically, with the speed of disks, the speed of how quick it is to restore a database in this day and age, I'm not that worried about restoration time anymore at those levels. For the most part, most of my customers are either doing volume level backup or they are doing just straight backups at the database level. Also, in some cases, in container native or cloud native databases are treated in a very traditional manner, and they're external to in some cases in enterprise anyway, they're external to your Kubernetes cluster. So you're accessing it as a custom resource definition, and you're still managing your database. Your database administrators are managing it and handling the backups the way they've always done it. So utilizing native tooling or.
So, Neal, I actually want to revisit something you touched upon a minute ago, which was reviewing and checking your backups. I cannot begin to tell you how important it is in the line of work that I do, managing multiple clients, to manually, and I mean manual, not automated, having someone check those backups and ensure that those data sets that we mentioned prior are backed up and are restorable the way that you expect them to be and documented. And I'll add on to that by saying, just because your data is in the cloud does not mean it's backed up. Those of you out there listening that are just getting into this field or have been put in charge of an organization, the first thing that I will tell you is to check your backups. Day one, when I onboard a new client, I check their backups. It's the first thing I do before I touch anything else. If you are in charge of technology for an organization, small or large, find out if your backups are working, make sure they're tested, and get documentation to show that your backup audit was successful. I have run into situations with clients where a client was hit with ransomware. They were backing up to an Azure Blob Storage. And what happened? The Azure Blob Storage was also hit with ransomware because the backup set wasn't set up to protect against that. And Neal, the agent-based backups that we talked about, that has seemed to help mitigate a lot. But I can't implore you enough. Don't believe that your cloud instances are backed up natively. Check and make sure that they are. Implement tooling to do that. And best practice, I would say, is every couple of weeks, run a documented backup routine, revisit it every couple of months or yearly to find out if your routine needs to change.
I'm going to emphasize one big important point. If you are in any cloud, read their responsibility guidelines. Amazon, for example, calls this the shared responsibility model. There are different terms for it, but every single hosted services provider, whether it's a cloud, VPS, whatever, they have a variant of this documentation. And I promise you, none of them say they're doing backups for you. So you need to do backups. And more importantly, you need to make sure they restore. And I cannot emphasize this. I cannot overstate how important it is for you to test and run and validate your own restores. Prove that they work on a regular basis and make sure you know that you can rely on them. Because when the day that you can't is the day you are screwed, and you do not want to be there.
Neal, you brought up a terminology that you mentioned it, but I don't think you explained it earlier. And either Bill or Neal, please define this. But the 3-2-1 backup strategy or schema, whatever you want to call it. Describe that. Like I've obviously heard about it, but typically when I get into the weeds here, I have a tendency to not explain it in simple terms. So I'll let you guys take this one.
Sure. Okay. Well, the 3-2-1 backup rule, to put it very concisely, is you have 3 copies of everything that you have, which is 1 primary backup and 2 copies of it elsewhere on different media. And one of those 2 copies needs to be somewhere physically somewhere else. Offsite is the term, but it's got to be somewhere else. Typically, the way that this works for a 3-2-1 strategy at a very basic level is, for example, on my computer, I have Fedora KDE with Btrfs. My home subvolume has my user data. I will take a snapshot of that user data. I will sync it to a external hard drive that I have, a portable SSD that I've got, and also to a cloud locker of some kind. That essentially ensures that I have 3 copies of the data, 2 of which that I have local, 2 of which that are local, and 1 that's offsite.
So my setup is sort of similar, but like I said, I have a NAS. So I have my live data set on the NAS. It's snapshots. I also have an external drive that gets rotated, and I have a second NAS at another location where that data is also saved. So that's, call it my 3-2-2-1 or 3-1-2-2 backup, but it's still multiple sets. Brandon, you have quite an interesting infrastructure set up in your lab. I'm very curious how you do your backups.
Yeah, so I have my main NAS, which is at the moment it's my own little thing. And then that replicates over WireGuard to a machine that is nearly identical at my parents' house. And I have a smaller, but has equal storage. It's just has two 15 terabyte drives and a RAID 1. That's also connected over WireGuard. And that one is at my brother's house. So I have a replication going to one and replication going to another. So I have two offsite backups. And here at my house, I have a similar system that's at my brother's house with those two 15 terabyte drives for my on-site backup. For a while there, I was taking a drive and putting it in a safety deposit box, but since I have two off-site backups, I feel like that was redundant, so I stopped doing that. And also, I was forgetting to take it back to the bank, so it doesn't really do much if it's just sitting here at your house in terms of a backup. So that's my current backup strategy: is two offsite backups with one backup here at my house.
So, Neal, you've worked extensively with some file system level backups before, namely BTRFS. And I can attest to that because you've been over my house and helped me with it before and taught me quite a bit about it. So many thanks to that. But can you help us understand how file systems handle, we'll call it internal backups or snapshotting, and what can you do with those? Where did those come into play where we've talked about volume level backups and application level backups? I feel like file system backups are kind of in between those two. And so how does that sort of fit in and work?
Sure. I will first point out snapshots are not backups. They are not a replacement for backups. They are not backups. Do not think of them as backups. The only way they turn into backups is if the snapshot is moved somewhere else. If it is on the same system, they are not backups. I don't know if I can say that enough, but snapshots are not backups on their own. Now, that being said, warning message aside, when file system and volume level snapshotting can serve functionally the same purpose because it actually depends on what level of abstraction you care about. So in a Btrfs system, you have a top level volume and you have subvolumes inside of it depending on your configuration. Like in Fedora, we have a top level volume and two top level subvolumes that have independent hierarchies. In OpenSUSE, you have one top level volume and all of the rest of the subvolumes are nested underneath it. These subvolumes can then be replicated using, if you're doing it mechanically, as in by hand, you use Btrfs subvolume create snapshot creator, whatever. You use the Btrfs tool to create the snapshot, and that creates essentially another subvolume that is either read write or read only, depending on how you configured it, that you have a complete referential copy of it. Now, a snapshot that exists on your system with Btrfs in particular takes up no additional space until you start changing the data to make a delta have in between. So at the point you create a snapshot, they're effectively identical and they take no extra space beyond like 16-ish kilobytes or something like that for metadata. I forget how much it actually takes for metadata, but it's not a lot. Once you start changing the data, either in the original subvolume or in the snapshot volume, then it creates a storage delta, and now you're taking up more space. And this dynamic space usage thing is the underlying nature of those of how snapshots work in a volume managing file system like Btrfs. And these properties also apply to ZFS if you're using this, like, say, on FreeBSD, or if you're using OpenZFS on Linux. The same principles apply. I'm talking about Btrfs primarily because Btrfs is in the kernel and everybody can use it. So it's very easy to experiment with. When you're talking about volume level stuff, like if you're distinguishing between file system and volume level backups, the most common comparison is often between Btrfs and LVM. LVM snapshots work a bit differently. While it is possible to do what's called copy on write snapshots, and again, this another terminology thing, copy on write refers to the technique where when you make a write operation, instead of changing the file in place, it duplicates the file somewhere else in the storage and makes the change on that duplicate location. The original one is left untouched. Now, in the real world, unless you freeze it with a snapshot that says that the original copy must stay, the original one is then deleted afterwards to conserve space. So it just flips the order of operations. So you do copy, write, then erase, rather than write, erase, in place. But this copy on write thing is essentially the core of how Btrfs snapshots and ZFS snapshots work. Volume managing file systems are often copy on write file systems. The upcoming Bcachefs is also a volume managing file system that is also a copy on write system. When you look at LVM, it is a volume managing block system. It's a block managed volume system. And that block volume system can be configured in a copy on write fashion, but by default it is not. Now, whether you have it in copy on write mode, which it calls thinly provisioned volumes, or you have it in normal mode, when you take snapshots, they're essentially creating the same level of, for thinly provisioned volume, it does the same thing that, say Btrfs or ZFS does, except it does it at the block level. Now, if you are using normal LVM, it does a full-on copy of the volume when you make a snapshot. So you're actually eating space immediately when you do that. Now, remember what I said earlier about how snapshots are not backups? The reason why snapshots are not backups is because they only turn into backups if you can move them somewhere else. LVM snapshots cannot go somewhere else. In Linux, we do not have a straightforward way to take a snapshot of a volume and put it somewhere else.
Quick note. I have been waiting all episode to trigger Neal about the fact that snapshots are not backups. I just want everybody to know that.
I suspected. And
but it's very important for that delineation to be made. And Neal, I wasn't aware of the fact that LVM snapshots could not be moved. And what that forces me to think about is what is the tooling and what is the file system that I want to deploy when I'm recommending Linux solutions to my clients? Because again, if we can't back it up easily, is it something that we should be implementing? And are there better or other alternatives that we could look at instead? So that's actually very informative. I appreciate that.
Yeah, well, sometimes you don't have a choice. So there is one notable Linux distribution, unfortunately, that does not offer Btrfs yet within its out of the box. There are ways to add it. There's a third-party repository in a community project. You can add, when you don't have Btrfs or you don't have ZFS or any of these volume managing file systems that provide you the capability to do this, you're going to have to go elsewhere to figure it out. And so if you remember earlier when I mentioned the data block driver, the reason it was originally written was because at the time, most distributions, the adoption of Btrfs was nowhere near where it is now. Having mainline distributions adopt Btrfs has changed the game when it comes to disaster recovery, if people wanted to take advantage of it. But when you are in a world where you don't have that, then you need to come up with another way. And so what the data block driver does is it gives you a way to take a copy on write snapshot of a volume as a file on the system that you can then sync off-site, essentially turning a snapshot into something that could be a backup. And that was the core of the Datto Linux backup agent. Still is. That it takes a snapshot of a volume and then it transports that snapshot somewhere else. And then it reconstructs on the other end the full system and then snapshots it with a volume managing file system. You can do it with Btrfs. Datto did it with ZFS. But like Datto BD was always intended to be paired with something where on the other end you had some kind of way of doing essentially re-implementing the snapshot, because you're going to turn it back into a disk image and you're going to snapshot the disk image. That is essentially the pattern that you're supposed to use. In the Linux world, your only real choice right now, if you want to have an out-of-the-box, straightforward strategy for doing disaster recovery, is to use Btrfs or to come up with some way to just do file-based recovery. Like if you want fast RTO, image or system-based full restore capabilities, Btrfs is pretty much the way to go. If you don't have Btrfs or you don't want to use it, then you need to look at other alternatives, mostly around doing things like application level backups, Rsyncs, things like relax and recover, which can kind of re-instrument what your system looks like and rebuild it. Like there's more sophisticated options out there, and we'll put links in the show notes for all the different things that are available. But it's all more complicated, right? Like when you lose the ability to take a snapshot of the system and then offsite it, you have to figure out a way to get that same capability. This is actually part of the reason why I keep harping on Btrfs in various different contexts, because I truly believe that making disaster recovery as simple as 3 commands that anyone can run is a very empowering and important thing to do. In the Windows and Mac world, they're edging towards this as well. If you look at macOS, they have switched over to the Apple file system, or APFS. That file system is a volume managing copy on writes file system that has snapshotting. There is a private API as part of APFS that lets you take a snapshot and move it somewhere else. Apple does not publicly expose this. This is not a thing that you are allowed to do normally. But I fully expect if it isn't done now, it will be done eventually, that Time Machine will use that capability. In Windows, ReFS is not a volume managing file system, but it is a copy on write one. Well, actually, it might be a little bit, because storage spaces. I don't know how the delineation works for Windows storage spaces. I'm a little out of the loop on that. Maybe you have more information about it. But the best I know about ReFS is they're also moving towards this world, just even more slowly than Apple is. But since you do Windows all day, can you maybe say some kind words about Windows storage spaces and ReFS?
Sure. I don't use them. I don't have a business need for them in my current line of business. We can test it out, but we're pretty traditional. I have a machine that I set up Hyper-V on for a client. I have a backup utility that I use that takes care of the on-site and the off-site backups. On-site backups would go to a NAS, and off-site backups go to our disaster recovery facility that we designed and built for quick recovery, because the backup software handles all the deduplication. It handles all of the versioning and the archiving to where it's pretty straightforward, and it has support for us when we have a problem with it. So as far as the advanced Windows ReFS and newer file systems go, I haven't had a need to deploy it yet with the current client set that I have.
That makes sense. I mean, I think the only case where I've seen Windows storage spaces and ReFS show up is really weird Exchange server setups, and those gross me out on multiple levels anyway. So I don't particularly feel like digging into that. But yeah, like in principle, if your system setup doesn't provide you a way to move a snapshot offsite, it is not a responsible or useful way to take backups, and you need to do something else.
In today's day and age, if you're still relying on an external hard drive rotation, that is a very manual process that's subject to error. And if you don't want to worry about your backups and you are in a tight budget, focus that funding on making sure your backups are good. Hardware is replaceable. Data is not necessarily replaceable. I can build you a fully functional VM server in a matter of 2 hours with the hardware I have at my office, and I can deliver it to you. I can plug it in, and I could walk away. But would your organization function? Probably not, because where's your data? So hardware always replaceable. Data replaceable if you make it so.
I think one of the traps that a lot of people run into though with backups is, especially with cloud backups, it's cheap to store it. It's expensive to get it out. Like it's quarters and quarters and quarters of a penny to back up to Amazon Glacier or and it's even then it's still, and even not on Glacier, say it's to Linode's object storage. $5, I think it's $5 a month for 250 gigabytes. Yeah, still getting that data out is expensive, but backups are expensive. That's just a fact. But automating your backups, whether to a cloud to the cloud though, is relatively easy. I think it's easier than when I first got into the space to do backups, no matter how automated it was, even with the giant storage tech automation robot for the tapes. There was still lots of manual work for some of the backup processes. Today, you're spoiled with options, and they're easily, and it's easy to automate and use.
One common place that I'm actually finding where people save their offsite backups, believe it or not, is to a Google Drive account. It's easy, it's inexpensive, and it has name recognition with just about everybody.
Also, it's a good API for integrating with. It's not a pain in the butt to actually plug into and use it.
I actually forgot I do have a job that backs up my home directory to my Google Drive account. So I guess I have 3 offsite backups.
The reason why I bring that up is because I know sometimes people will panic about, oh my goodness, where am I supposed to back up this data set? I feel like there's a sense of urgency here. And the whole point of it is there's an answer right under your nose, and you probably already have it, which is backing up something to Google Drive. And no matter what you want to think about privacy, security, whatever else, you can always encrypt that backup as a tar file and send it off to Google. It's not like they're going to be able to open it. So don't be correct. Rsync is a great tool that will do it for you. So why not use the tools in the storage that you may already have right under your nose?
For what it's worth, Deja Dupe, whatever you want to call it, in GNOME, actually uses Rsync to back up to Google Drive and will happily configure it for encryption for you and all that stuff.
I think it just moved to a Rsync backend.
Yeah, it made the move like I think a year or two ago. It's pretty new. I use it for my laptops because the nice thing about that is if everything goes horribly wrong and I need to borrow or get another laptop for some reason, I can actually just pull that data like right away. But I don't back up my entire system. I'll back up like actually important stuff. And because I have a very structured setup for my home directory, that is possible for me to do. And again, this is part of my 3-2-1 strategy of making sure I have, or rather, not my 3-2-1, but my belt and suspenders strategy. My belt and suspenders to have like another way to get really important data quickly if I need to.
So we've talked about some easy backup methodologies. What I want to do now is bring it up to the next level, and I'm going to mention a tried and true but very scary tool that we've all used and used horribly at some point in our careers, and that's Rsync.
Rsync is, I love it. I also hate it. But one of the things I really like about Rsync, even when copying files on the same system, the copy command, yeah, there's flags you can use to prevent access time and file modification time. But Rsync can do that not just across on your system, but across the network as well. Like you can save those attributes. And this was really critical in one of my early jobs in my career, because that access time, the create time was really, specifically create time, was really important when this data was moving from one system to the next. So if I'd get a file, we would actually use the create time of that file as part of, to demonstrate to a standard, to an audit body that we actually received healthcare claims at the appropriate time. And if you change that, if the create time is different, you run into problems with this particular software, and also the way it was being handled when it had to be transmitted to. Anyway, that's just how we handled it, and it made it so it was really, really important, and that's still happening. And I know in other places, because that software is still in use in the healthcare space. So it's important to understand that you need to use it. You can't just do a copy or an rsync without flags that save specific attributes, especially time attributes. And I think that's why rsync is, I love and hate it, but because it works really well when it does work, but when it breaks hard. Usually when it breaks hard, it's usually the person, the piece of meat between the computer. That's right before the keyboard. So that's me. Right at the get-go, we talked about what. And I think that what to back up. Think about what you can't replace. That again, that's your application data, or don't worry about configuration. Obviously, back up your configuration, Ansible playbooks and things like that. Those are reproducible still. Those are still reproducible, though it could take time to rewrite your playbooks, rewrite your Ansible roles, or your Puppet manifests. The strategy, like on the how, what to use. And you guys made a really good point. Pretty much all throughout this, if you don't test your backups, they're useless. From my point of view, an untested backup is not a backup. If you're responsible for your family's data, if you're responsible for your company's data, test your backups, make sure that everything is in a good state. When I was in ops, we'd test backups once a quarter. Typically after a quarter close, can we restore from backup? I feel like that's still a good practice to this day. Any other wrapping thoughts, guys?
Snapshots are not backups, and backups need to be tested to be backups.
Don't trust that your cloud provider is backing up your data. Read the agreement that you have with them. Understand your responsibility and their responsibility and the concept of shared responsibility. And as my two esteemed colleagues here have said, test your backups.
Thank you for listening to the Sudo Show, where business meets open source.